Assalamu alaikum, dear students. Today we will solve some numerical problems which are from the NCRT textbook. So, very first numerical is 2-point charges QA equal to 3 microcoulombs and QB equal to minus 3 microcoulombs are located 20 centimeters apart in vacuum. Then, first of all, we have to calculate electric field at the midpoint O of the line joining the two charges. Number second, if a negative test charge of magnitude 1.5 into 10 to the power minus 9 coulombs is placed at this point, means at the midpoint, then what is the force experienced by this test charge? So we will solve one by one. So part A. So two charges, 2-point charge, QA equal to minus 3 coulombs, 3 microcoulombs, and QB equal to minus 3 microcoulombs. So QA is equal to, that is 3 microcoulombs. So this is equal to 3 into 10 raised to power minus 6 coulombs. We know that 1 microcoulomb is equal to 10 raised to power minus 6 coulombs. Similarly, we have another charge, that is QB that is equal to minus 3 microcoulombs. So that will be equal to minus 3 into 10 raised to power minus 6 coulombs. 10 raised to power minus 6 coulombs. Now these two point charges are located 20 centimeters apart in vacuum. So we'll take here charge first. So here it is charge first. It's at a distance of 20 centimeter. 20 centimeter. So it is charge first QA. Now this is QB. Magnitude of this charge, that is 3 into 10 raised to power minus 6 coulombs, and the magnitude of this charge is 3 into 10 raised to power minus 6 coulombs, minus 3 into 10 raised to power minus 6 coulombs. But we have to calculate the electric field. हमें इलेक्ट्रिक फील्ड निकालना है, but at the midpoint of this line joining the two charges. So this is the midpoint. So this will be the midpoint of the two charges. We represent it as O. Now at this point, we have to calculate the electric field. Due to both the charges. First of all, we will calculate the electric field at O due to this QA. We have already discussed electric field at a point due to a single point charge. We know that this electric field, so this will be E, we represent it by A. So that means electric field at point O due to QA. So we can write it as that is equal to, हमें मालूम है कि electric field intensity at a point due to a single point charge, we have already calculated it, that is 1 divided by 4 pi epsilon naught Q divided by R square. Now here we will see what's R. So R is equal to 20 centimeters. So it's in the CGS system. We have to change it into SI system. We can write here R is equal to, so this will be equal to 0.2 meters. 0.2 meters. Or we can write here EA is equal to, so this 1 divided by 4 pi epsilon naught, that is equal to, it's a calculated value, that is equal to 9 into 10 raised to power 9. So we'll write here 9 into 10 raised to power 9 into Q. So Q here, the charge is, so that means basically we have to calculate the field, electric field at this point, but due to this charge, so that means the magnitude of charge is here, so that is 3 into 10 raised to power minus 6 coulombs, 10 raised to power minus 6 coulombs. So here divided by, now this R, so R is here 0.2, so it is 0.2 but whole square, it is 0.2 whole square, 0.2 meters whole square. So sorry, the distance is here. So distance is not here, 0.2. So the overall distance between the two charges, that is 0.2. So that means the distance from QA to QB, that is 0.2. But the distance from center to this QA, it is 0.1. So here it will also be 0.1. So we'll write here R जो है that is equal to 0.1 whole square. 0.1 whole square. Now this 0.2, that's the overall distance between the two charges. But from the center to the charge A, the distance is 0.1, and from the center to the charge B, distance is 0.1. And the overall distance, that is 0.2. So here, but we have to calculate the electric field intensity at this point, at point O, due to the charge QA. So we'll take this distance 0.1. So 0.1 whole square. Or we can write here electric field intensity at electric field at point O due to QA. So this will be equal to EA is equal to. So here it will be, or we can write here 9 into 10 raised to power 9 into 10 raised to power 9 into 3 into 10 raised to power minus 6 whole divided by. So this will be 0.1 into 0.1. So this will be 0.01. So this will be 0.01. This will be 0.01. Or we can write EA is equal to. So here 0.1 into 0.1. So that is 0.01. We can write here. So this will be 27 into 10 raised to power. So it will be 10 raised to power 3 into. So this will be here 1, or we can write it as, so this will be 1 into 10 raised to power minus 2. So here it is 10 raised to power minus 2. So 1 divided by 100, so that will be equal to 1 into 10 raised to power minus 2. Or we can write EA is equal to 27 into 10 raised to power 3 into, so 10 raised to power 2. 10 raised to power 2. Or electric field at point O, or due to charge QA, means due to A charge, or we can write it as A. So this is charge B. So that will be equal to, so we can write 27 into 10 raised to power 5. 10 raised to power 5, or EA, electric field at point A, that is equal to. So I can write in this way 2.7 into 10 raised to power 5, or electric field intensity A, electric field at point O due to A. So that will be equal to 2.7 into 10 raised to power into 10 raised to power 6 into 10 raised to power 6. So this will be into 10 raised to power 6. But what is the unit? We know that electric field, if we define this electric field intensity, that is equal to force acting on the charge. Force acting on the charge. So unit will be here. So it will be Newton per coulomb. So here the unit is Newton per coulomb. So this is the electric field at point O due to this charge, 3 into 10 raised to power minus 6. So that is 2.7 into 10 raised to power 6 Newton per coulomb. But what is the direction of the force? So direction of force is, so this force, so force acts on this point, but in this direction. So this will be the direction. So this will be the direction here. So this will be the direction of force. So we can write it as EA. So direction of force is along this direction. Because here we have 3 into 10 raised to power minus 6 coulombs. So that this 3 into 10 raised to power minus 6 coulomb, it exerts force at this point, but in this direction. Next, we have to calculate electric field at this point, but due to this charge, QB charge, minus 3 times per minus 6 coulombs. And then after that, we will see what is the direction of the force, or the direction of the electric field. I will rub it. Similarly, We will write here electric field, electric electric field at O due to minus QB. Due to QB, we'll write here due to QB. The same formula, we will apply the same formula. The formula is EB. We can write here. It means that electric field at point O due to B charge, due to second charge, that is minus 3 into 10 raised to power minus 6 coulombs. So that is equal to, according to the formula, 1 divided by 4 pi epsilon naught Q divided by R square. Q divided by R. So here it is R square. R square. Or we can write here EB is equal to, so this 1 divided by 4 pi epsilon naught, it is 9 into 10 raised to power 9 into, so Q, the magnitude of charge, second charge, that is 3 into 10 raised to power minus 6 divided by, and the distance, that means the distance from this charge to the center, that is 0.1 whole square. 0.1 whole square. ओके तो हम आगे बढ़ेंगे. EB is equal to, so that is here, this will be 27 into 10 raised to power 10 raised to power 3, 10 raised to power 3 divided by, so this will be 0.1 into 0.1, that is 0.01, or we can write EB is equal to 27 into 10 raised to power 3 into, so this will be here divided by, so right, it has 1 into 10 raised to power minus 2, 1 into 10 raised to power minus 2, or EB is equal to 27 into 10 raised to power 3 into 10 raised to power 2, or EB is equal to, this EB means electric field at this point, at point O, due to charge of B, that is 27 into 10 raised to power 5, 10 raised to power 5, so this will be 10 raised to power 5, or EB is equal to 2.7 into 10 raised to power into 10 into 10 raised to power 5, or here we'll write EB is equal to this is 2.7 into 10 raised to power 6, and the unit is, so here unit is unit of electric field, that is electric field intensity, or we can write here, so that is a Newton per coulomb. So this is the direction, this is the magnitude of the field at this point, at point O, due to charge second charge, or we can say due to charge QB. But what is the direction of charge? So here we see it's a negative charge, so it will attract this, it will attract this towards itself, so direction will be this, so this will be the direction, this will be the direction, so we can write it as EB, so this is EB. So this was the first part, but we have to calculate the total field. What is the electric field at the midpoint? At this point, the electric field at the midpoint due to both the charges QA and QB. QA and QB. So we'll calculate electric field, electric field at O due to these two charges, these two charges. So that will be, we'll represent it as E is equal to EA plus EB. EA plus EB. So it will be E equal to, that is equal to EA. We have already calculated EA. So that was 2.7 into 10 raised to power minus 6 coulombs plus EB, that's also 2.7 into 10 raised to power minus 6 coulombs, Newton per coulomb. Or we can write here E is equal to, So this will be 4.5 into 10 raised to power minus 6. 10 raised to power minus 6 Newton per coulomb. Newton per coulomb. So this is the electric field at point O, at the center of the line joining between the two charges. So it was the first part of the numerical. तो आपने देखा यहाँ पर कि तो डायरेक्शन ऑफ इलेक्ट्रिक फील्ड कहाँ की तरफ है. So direction of electric field is same in both the cases. तो पार्ट सेकंड जो इसका है, सेकंड पार्ट ऑफ द न्यूमेरिकल, दैट इज if a negative test charge of magnitude 1.5 into 10 raised to power minus 9 coulombs is placed at this point. That means a negative charge of 1.5 into 10 raised to power minus 9 coulombs is placed at the center of the line joining the two charges. So we have here first charge. So it is first charge. It is the second charge. Here is the second charge. Now at this is the center. This is the center. So it is point. This will be QA. So this will be QB. And the magnitude of this is 3 into 10 raised to power minus 6 coulombs. And the magnitude of this is 3 into 10 raised to power minus 6 coulombs. But it's minus. So here is the center. This will be the center O. And center from this charge radius is 0.1. Distance is 0.1 here. Distance is 0.1. But minus Q. So here a negative test charge of magnitude 1.5 into 10 raised to power minus 9 coulombs is placed at this point. That means a charge of minus Q is placed at this point. Then we have to calculate what is the force experienced by this test charge. So we'll see here. We have to calculate the force. So we'll apply the Coulomb's law. We know that according to Coulomb's law, the force of attraction or the force of repulsion between the two charges, between these two charges, or we can say between these two charges, that is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. So first of all, we'll calculate here force between QA and QB. Yeah, force experienced by this test charge. इस तरह आप लिखेंगे. So we'll write force experienced by minus Q due to force experienced by minus Q due to QA. So we'll apply here. We can write it as FA. That means force acts on this test charge due to QA. So that will be equal to, according to Coulomb's law, that is equal to 1 divided by 4 pi epsilon naught Q1. So that is Q1 is here. So Q1. So we can write it as Q1. So here Q1 is 3 into 10 raised to power minus 6 into Q2 is. So here it is और 1.5 इसका मैग्नीट्यूड है, so that is 1.5 into 10 raised to power minus 9. So we can write it as 1.5 into 10 raised to power minus 9, 10 to the power minus 9 divided by the square of the distance between them. So here the distance between these two, that is 0.1 whole square, 0.1 whole square. Okay, so we'll write here FA is equal to, so this is 9 into 10 raised to power 9 into 3 into 10 raised to power minus 6 into 1.5 into 10 raised to power minus 9. So divided by, so this will be 0.01, 0.0, 0.01, 0.01, or we can write FA. FA is equal to, so this is this will be 27, 9 into 3, that's 27, 27, okay, into 1.5 into 1.5, 1.5, so this is 1.5 into, this will be, it is 10 raised to power 9, so this and this will cancel, so it will be 10 raised to power minus 6. So here 10 raised to power 9, 10 raised to power 9, so it will be, ये cancel हो जाएंगे, so this becomes, so here it's 10 raised to power minus 6, okay, divided by, so divided by, it will be 1 into 10 raised to power minus 2 here. So we can write FA is equal to, so this will be 27 into 1.5, so this will be 40.5, 40.5, 40.5 into 10 raised to power minus 6 into 10 raised to power plus 2, or we can write FA is equal to, so this will be, this 40.5, it will be 4.05 into 10, so that will be 40.5, that will be 40.5 into 4.05 into, yes, so it into 10 raised to power minus 6 into 10 raised to power 2 into 10 raised to power 2, or we can write FA is equal to, so this will be 4.05 into, so it will be 10 raised to power minus 3, 10 raised to power minus 3, so the unit will be newtons, unit will be newtons. So this is the force experienced by this test charge, by this negative test charge due to QA, due to QA. Second, we will calculate the force experienced by this negative charge due to QB. So the direction of force will be, so here it is the, it is positive charge and it's the negative charge, so it will attract this in this direction, so ये यहाँ की तरफ होगा, so this will be the direction, तो आप यहाँ पर लिख सकते हैं it is FA, so direction यहाँ की तरफ, so this will be the direction. These are very important numericals which are usually asked in the board exam as well as competitive exams. So next, so similarly, so we'll calculate the force experienced by this negative charge, that's whose magnitude is 1.5 into 10 raised to power minus 9 coulombs, or due to this QB. Force experienced by minus Q, or due to due to force experienced by minus q due to q b, due to q b. So that will be, so I will write it as fb. So that means force experienced by this charge, by this test negative charge due to qb. So that is equal to 1 divided by 4 pi epsilon naught. So q1, so here q1 is this 3 into 10 raised to power minus 6 into qb. So that's 1.5, 1.5, that is 1.5 into 10 raised to power minus 9 divided by the distance, square of the distance between them, that is 0.1 whole square, 0.1 whole square. Or we can write fb is equal to, so this is 9 into 10 raised to power 9 into 10 raised to power 9, 9 10 raised to power 9 into 1.5 into 10 raised to power, sorry, it is 3.10 raised to power minus 6, 3 10 raised to power minus 6 into 1.5 into 10 raised to power minus 9 divided by, so this will be 0.01, 0.01, 0.01, 4.0 into 10 raised to power minus 3. Okay. So FB that is equal to, so this will be 9th, that's 27 into 1.5, this 1.5 into 10 raised to power, so 10 raised to power 9 into 10 raised to power minus 6 into 10 raised to power minus 9, 10 raised to power minus 9 divided by 1 into 10 raised to power minus 2, 10 raised to power minus 2. So here it will be fb is equal to, so this will be 40.5 into 10 raised to power, so this whole will be 10 raised to power minus 6, 10 raised to power minus 6 divide into this will be 10 raised to power 10 raised to power 2, 10 raised to power 2. So yeah, or we can write fb is equal to, so this will be 4.05 into 10 raised to power minus 6 into 10 into 10 raised to power 2. So fb is equal to 4.05 into 10 raised to power minus 3, 10 raised to power minus 3. So force, so unit of force, that will be Newton, that will be Newton. But what's the direction? So if you see the direction of this force, so it's a negative charge, it's also a negative charge, so it will repel it. So the direction of this will be along this. So this will be the direction of force. FB So this is the direction of force. Now the total force, total force, total force, force experienced, total force experienced by minus q due to qa and qb. So that will be total force F, that is equal to fa plus fb. So total force, that is equal to fa. What's fa? So that was 4.05 into 10 raised to power minus 3 plus 4.05 into 10 raised to power minus 3, 10 raised to power minus 3. So if you add them, so F will be equal to, so this will be 0, yes, 1.88 into 10 raised to power minus 3 newtons. And this power is 10 newtons. So this is the total force experienced by this test charge, negative test charge, due to these two charges. So it was the first numerical.